let's see the bloom in the field again. Okay, so this is the blooms in 2008 and in 2009. This line shows Cochlodinium concentrations in the selection experiment. So you can see during blooms, especially 2009, cell densities of Cochlodinium in the field are higher than Cochlodinium concentrations in the lab study. Okay. And we know the generation time of the copepods is about 2 weeks in summer. So about 2 generations are exposed to selection force in the field, so which could result in evolutionary changes in the field population. And I can tell you, I performed the field sampling for common garden experiment at the end of the bloom in 2009. So it is not surprised that copepods in the bloom area are more resistant to Cochlodinium. This is the summary of my PhD work. The interactions between the Cochlodinium and the copepods are likely to result in an arms race. So you can see at high cell densities, Cochlodinium can produce multiple harmful compounds, which can reduce copepod survival, feeding, and reproduction. Okay. However, Cochlodinium is beneficial to copepods at low cell densities. Cochlodinium can form the long chains to reduce the grazing mortality. Okay. On the other hand, copepods can rapidly evolve resilience to Cochlodinium during the bloom time. However, copepod resistance can be rapidly lost during the non-bloom time. Okay. Although it seems my study have answered some questions, but they also put forward more new questions. We know the nutritional value of the Cochlodinium is density dependent, but we don't know whether it is a common character for other harmful algae. We don't know. We know some chemical compounds can regulate the interactions between the Cochlodinium and the copepods, here and here. But we don't know their structures. We don't know the mode of actions. We don't know their biosynthesis. We don't know. We know copepods or Cochlodinium can use chemical defense and morphological defense to reduce grazing mortality. But we don't know whether these defenses are directly caused by grazers, or they are just byproducts. Okay. We know copepods can rapidly evolve and lose resistance to Cochlodinium, but we don't know. But we don't know the mechanism of these evolutionary changes. We don't know the cost of these evolutionary changes. Okay, we don't know. We know adaptation and counter adaptation can shape the interactions between the harmful algae and the zooplankton. But we don't know how they affect the ecosystem functions. We don't know. And I believe all these unknown questions have offered good topics for the future studies, which will generate a better understanding of interactions between harmful algae and the zooplankton. Now it's time to say thanks. I thank my advisor, Darcy, for her encouragement, guidance, and support during my PhD study. I also want to thank Chris for his decision which made this research started. Both Darcy and Chris have provided many valuable comments, suggestions, and benefits for my manuscripts. Thanks. I also want to, and my other committee members, Jack, Bob, and Hans, all provided their input during different stages of my studies. And finally, thank you everyone for coming here and listening to my stories. Hopefully you can enjoy them. Thank you.
Sure, if you have, take some questions.
Yes.
Thanks. I guess this is just to make a speculation. So for the field work, blooming area and the non-blooming area of Cochlodinium, so what would you expect if you just sample those two sites at the non-blooming period? Would you see the difference in the resistance of the copepods? I mean, you sampled during the bloom, so there was difference between the resistance, but what would you expect to see if you sampled there in non-blooming period? Would you expect to see?
You may or may not see the resilience if you sampled the non-bloom time. Probably the resilience can be rapidly lost during the non-bloom time, but maybe the resilience is still there. It still is time to lose this resilience because the resilience is genetically based. So I don't know if you sample if you get your sample from the non-bloom area. I don't know the result, but I think you can get the two results. One is the resilience is totally lost. Another is resilience is partly lost. So we should do this research to test their resilience during the during bloom times and the non-bloom times to see how this resilience changes with the time. So
because I just wondered if they have a difference even in the non-blooming period.
Yes.
Can I ask a non-scientific?
Sure.
What do you think you benefit most from studying here?
From here, independence.
I asked this after this, but you probably would just shrug off it. So
I think. I think my advisor Darcy, she created a perfect environment for me to develop independence. I like this free. So you can do everything you want. So and I like this. Yes.
That works for some students.
Yeah, it's a great presentation. I mean, I have to admit, I'm a classmate of his, and I'm still here waiting to graduate, but he's already,
Independence? I think the independence is very important for PhD students. So and I appreciate that. Darcy gave me this freedom.
Not totally.
Not totally. Yes.
First question is regarding the gain and the loss of the resistance.
Yes.
In copepods. Since the gain and loss of this resistance can occur just within 2 generations or very short time period.
Yes.
Right? So you use the word evolution. I'm wondering, I'm not very familiar with the theory of evolution. My guess is normally if we use evolution means there's some genetic change.
Right.
But since this gain and loss of resistance can occur in such a very short time, so I'm wondering whether this change just is a physiological or biochemical change, but not at the level of genetic or DNA level.
This is a good question. So any phenotypes changes can be caused by genetic or by the environment factors. So for the common garden experiment, it is very important that you incubate all populations in the lab at least for 2 generations. So 2 generation incubation in the lab could minimize the environmental effects. Then you compare their phenotype difference. If you see the difference, probably this difference is genetically based. So in the science